Hello, this is Susan Poss, and I'm going to work a little bit today in section 3.4, solving linear inequalities. And this is my first video, so I've numbered it 3.4.1. So when you're talking about linear equations, that is something that we learned how to solve in chapter 2, and we came up with one answer. Maybe x equals 5, so there was one solution. When we work in this section with linear inequalities, these are going to have an infinite number of solutions. So instead of getting something like x equals 5, we will get an answer that says x is greater than 5. And of course, there are infinitely many values that are greater than 5. So 6, 5.5, 3 million, there's infinitely many numbers that are greater than 5. So here are symbols that we're going to be working with. We've got less than, greater than, less than or equal to, greater than or equal to. And the way we're going to symbolize these on a number line is going to involve parentheses and brackets. So when the number is not included in the graph, we will be using parentheses. When the number is included in the graph, we'll be using brackets. So the parentheses will go with the strict is less than or the strict is greater than. The brackets will be used when it's is less than or equal to, meaning including that value, or greater than or equal to. So these are the ones for brackets down here in the second category. All right, so here we go. We have something written here above the number line that says parentheses -3, comma, infinity, parentheses. So the way we're going to symbolize that, I'm going to just call that one 0 because down here is -3. So what's going to happen is we're looking at not including the -3. We're going all the way out to positive infinity, and so that will include all of the values in here and all the way out to positive infinity. That's the way it looks when we graph it. Okay? When we graph it. When we write it as an inequality statement, we'll be looking at numbers that are greater than -3. Notice we're not including -3 because we have parentheses at the -3. All right, so taking a look at the next example down here, we have parentheses, -infinity, comma, 4, bracket. So again, let me just put something here for 0, and that means that number, a specific marking out there, that hash mark will be positive 4. So we're starting down here at -infinity. Notice for infinity, when we're at the infinity side, those are always going to be parentheses because we can't ever reach that point. And then we're going all the way up from that point at -infinity, which we cannot reach, all the way up to including, so there's our bracket, including the positive 4. So that's the way it looks when we graph it on a number line. When we look at it in an inequality statement, we would be looking at x less than 4. So that would include all the numbers on the number line, all real numbers that are less than 4. All right, so here's some when we look at the inequality notation, and we have to put it into interval notation and write and graph it on the number line. So let me pick a value here, and we'll call this where the location of 0 is. I want to show you all the values that are less than 0, so those are down in this direction. So I'm going down to -infinity. And am I including the 0? It doesn't say less than or equal to 0, it just says less than 0. So I will put the parentheses here. And notice how I curve the parentheses in the direction of where the numbers are located. So that's the way it looks when I graph it. And when you write it in interval notation, it sort of just follows the way the number line looks. And again, notice that because I'm working with infinity, I don't close down that notation. And the last one, before I stop this first video, says y greater than or equal to 5. So I'll just say this is 5 here. The numbers that are greater than 5 are out here in this direction, and we'll be going all the way out here to positive infinity. And the question becomes, do I include the 5 or not? And yes, I do include the 5 because it says greater than or equal to 5. And again, notice I turn the bracket in the direction of where the numbers in the solution are located. And when I put it in interval notation, I'm just basically following the notation that I see on the number line.